Okay, today we're going to go ahead and finish section 5.1, bookwork 3, which is 52 through 72. And I'm going to be really honest, this is a really difficult section, so I need to make sure that you guys are studying and that any problem that I have done for you, that you are making sure that you're redoing by yourself. A lot of the problems that I do today, some will be odds, some will be evens. You are responsible for all of them, even though they have not all been assigned to you. So you need to make sure all of them are fair game for the test. Now, instructions are super important today. These instructions will tell you exactly what you need to do and what the expectations are. So let's go ahead and read the instructions, starting off with problems 52 here. So if we're talking about problem 52, it says down here, in exercises 51 through 60, factor the expression and use the fundamental identities to simplify. Use the graph utility to check your result graphically. The directions are telling me the key word is factor. I need to factor, and then I need to use my identities. So that is exactly what our game plan is going to be. So if I say that I'm supposed to factor, whenever I say the word factor, your brain should be thinking GCF and then two binomials. So what is my GCF? This is my first term, and this is my second term. What is in common between the first term and the second term? If you said cotangent squared, you are right. So if I pull out a cotangent squared of x, what remains whenever I do division, cotangent squared divided by cotangent squared is 1. And then what remains on our second term is a cosine squared of x. Now, after we apply our lovely little factoring, it says to then apply your trig identities. Well, the trig identities should then tell you that 1 minus cosine squared is equal to sine squared of x. Then your brain should look at this and say, hey, I have a foundational trig function in my problem. So that means all of them need to be in terms of sine and cosine. So that means the cotangent squared is now going to become cosine squared of x over the sine squared of x, and then I'm multiplying that by the sine squared of x. Sine squareds cancel, and I'm left with, whoopsie, and I am left with a cosine squared of x, and that is done. Okay? So that is how you do problem 51. Now 55 has exactly the same instructions still. These instructions say to factor and then use the trig identities. Well, this is a trinomial. This trinomial needs to be broke down into two binomials. So how do I split up anything to the fourth power? That's going to be tan squared of x and tan squared of x. How do I split up 1? That's a 1 and a 1. And I need to have a positive 1, and then my middle term is positive, so that's plus and plus. Again, keeping in mind what the directions said, it said to factor and then use the trig identities. Well, what is tan squared plus 1? Tan squared plus 1 is secant squared of x, and we are going to apply that 2 times. Secant squared times secant squared is going to be secant to the fourth of x, and that is done. Okay? 58, still factoring and using our trig identities. Well, I have 2 terms, and again, it's to the fourth power. So I need to go into 2 binomials. So that means I have secant squared of x and secant squared of x. Tangent squared of x and tangent squared of x. Again, we're just applying our algebra 2 information. One is positive and one is negative. Again, using the instructions, it says to then use Pythagorean identities. Well, your brain needs to be recognizing that we're using our trig identities here. So if we're using our trig identities, that means that I'm using this right here. That means that if I put the secant squared and the tangent squared on the same side, that means secant squared of x minus the tangent squared of x is going to be equal to 1. So if I go back over to what I was working on, secant squared minus tangent squared is simply going to be the value 1, and I have a secant squared of x plus a tangent squared of x. And that is as far as your textbook wants you to go today. Okay? Problem 62. Problem 62, the directions say, in exercises 62, perform the multiplication and then use the fundamental identities to simplify. So they want you to multiply. So if I'm multiplying here, that means I need to FOIL. Look at these lovely little binomials. They are exactly the same binomial except for the signs are opposite. Those are what we call conjugates. When you FOIL conjugates, you do the first and you do the last. After you FOIL, it says to apply the identities appropriately. So let's go back to our identities. If we go back to our identities, what you are going to notice is that we are talking about this right here. Cosecant squared is equal to 1 plus the cotangent squared. So go back over here. That means I have the cotangent squared of x minus the quantity of 1 plus the cotangent squared of x. I drop the cotangent squared of x down. I distribute the 1 and distribute the cotangent squared. These cotangents cancel out, and I'm left with -1 as my answer. Now, did you have to do the purple work that I showed right here? No. You could have automatically said that from here, it was -1 if you saw it. Next, number 66. Number 66 says to go ahead, and here it says, perform the addition and the subtraction and use the fundamental identities to simplify. So when you are adding or subtracting two fractions, you have to get a common denominator. I do not love a subtraction. I prefer addition, so I'm going to make this a -1. I'm going to change a subtraction to addition. I need an LCD, and that is going to be each of these denominators attached together. So I have two fractions with that denominator. Secant of x plus 1, secant of x minus 1. Secant of x plus 1, secant of x minus 1. I drop down the 1 for each one of them. First fraction's a 1, the second fraction's a -1, and I'm going to tack on what I need to multiply by. Well, this needs a secant of x minus 1, and over here, this needs a secant of x plus 1. So now I'm going to write this as one fraction. And I'm going to drop the parentheses, distributing here, making that a minus secant of x minus 1. What you're going to notice is those secants cancel out, and I'm left with -2 over. This is a secant squared of x, and this is a -1. Let's go ahead and use our trig identities. So if we use our trig identities, secant squared minus 1. So if I'm using this right here, secant squared of x minus 1 is equal to your tangent squared of x. So I'm going to come back over here, and this becomes a tangent squared. So now I have -2 times 1 over the tangent squared of x. Well, what is 1 over the tangent squared of x? That is going to be the cotangent squared of x. And as you can tell for number 66, if you check your answer key, this is going to be the correct answer. Okay? Now, with number 67, the directions still are saying to subtract them. I'm probably not going to do this one because you're going to put this over 1 and you're going to go ahead and get tangents for your denominator. So I will set you up, and you're going to want an LCD of a tangent. So this is going to be the tangent of x, and this is going to be the tangent squared of x, and this is going to be the secant squared of x over the tangent. Marry them and apply your LCD, or apply your identities. Over here, number 72, the directions are a little bit different. The directions over here say rewrite the expression so that it is not a fraction. In order for it to not be a fraction, you have to multiply by its conjugate. And what you do to the bottom, you do to the top. So this is going to be the tangent squared of x times the cosecant of x minus 1, and then we're going to FOIL the bottom, making that cosecant squared of x minus a 1. Well, what is cosecant squared of x? Well, if you go back to your identities, cosecant squared of x minus 1 is simply going to be cotangent squared. So I have the tangent squared of x times the cosecant of x minus 1 all over the cotangent squared of x. Now, your brain needs to recognize that it's still a fraction, but this is in the denominator. So if your brain doesn't like to see it that way, rewrite this as 1 over the cotangent squared of x times the tangent of x times the cosecant of x minus 1. This is actually going to be tangent squared. So I have tan squared of x times the tan squared of x times the cosecant of x minus 1. And these two together is going to give me the tangent to the fourth of x times the cosecant of x minus 1. And the goal was for it to not be a fraction. And it is not a fraction. So if we check our answer for problem 72, and if we look at problem 72, tangent to the fourth of the cosecant of x minus 1 is our answer, and we know that we are correct. And we did that by multiplying by the conjugate. On number 69, it is going to be very similar to that. 69, you're going to multiply by the conjugate of that. And when you do it, you're going to have the same philosophy. What you do to the bottom, you must do to the top. And I'm going to let you guys finish that one. Super important that you guys are asking questions and that you're writing notes to yourself so that whenever you come to class the next day, I can answer any questions you have.